This is 12-1, lines that intersect circles. Our focus this chapter is going to be on circles. Let's take a look at the warm-up. So remember that when you write an equation of a line, like for FG, that's an undefined slope. And so when we write equations, that's an x equals equation. So in that case, for FG, it's going to be x equals, and it's at -2. Write the equation of the line for EH. Well, that's a zero slope. So we could use point slope if we want to. We could do like y minus y1 equals m parentheses x minus x1. And we could fill in a point and a slope. Or we can use y equals mx plus b. So I need to know the slope, which is 0, and the y-intercept, which if you extend the line would hit at 3. So then therefore I have y equals 0x. We don't write that, so we would have just 3, y equals 3. So when we have a horizontal line, it's an undefined, it's a zero slope. This is my undefined line, EH, and that's going to be a y equals equation. And when we have a vertical line, it's an x equals equation. So it's some algebra review for you. And then solve 3 and 4 and hit play when you're ready to see the answers. There are the answers to the warm-up. X equals 16 and x equals 8. I don't think I need to say too much about these two vocab words. Interior of a circle is inside the circle, and exterior of the circle is outside of the circle. Here's some important vocabulary. A chord is a segment whose endpoints lie on a circle. So for instance, we have chord AB. It does not go outside of the circle, it lies on the endpoints. So a line that hits the endpoints. A secant is a line that intersects a circle at 2 points. So the secant goes through the circle. And a tangent is a line in the same plane as a circle that intersects it at exactly 1 point. So here's the tangent, and it only hits at this 1 point, which we call the point of tangency. So we're going to have to name some of these lines and line segments. We have to be careful how we name those. So in example 1, we have to name all of the chords that we see here. So for the chords, we have line segments KM and JM. So remember, they don't go through the circle, so they just hit the endpoints and they stop. So that would be KM and JM. So a chord can be part of a secant, or yeah, it can be part of a secant. Okay, so a secant now. For the secant, we have line JM. So I need arrows on either side just to show that it's a secant, that it's going through, it's intersecting, crossing through at 2 points. And the tangent, we can call that line M. We're only given one letter, H, so we can't call it like, AH or something like that. So the tangent would be line M. That's a cursive M. And then the diameter, well, we know that a diameter goes through, the diameter cuts through the center of the circle and is a chord. So that would be diameter KM, line segment KM. And for the radii, well, a radius is half of the circle, so K to L, for instance, is one of them, but there can be more than one. That's why we call it radii when it's plural. So KL, JL, and LM. So do the now you try and hit play when you're ready to see the answers. So notice where I have lines versus line segments. So just take a second to make sure that you have the correct lines versus line segments that I have. So chords, line segment, QR, and ST, for example. Okay, some information you need to know about circles. So two circles are congruent if and only if they have congruent radii. So therefore, if radius AC is 4 and radius BD is 4 meters or whatever, then the circles must be congruent circles. Concentric circles are coplanar circles with the same center. I believe that's a membrane word for some of you. So concentric circles are coplanar with the same center, like a circle around a circle. two coplanar circles that intersect at exactly one point are called tangent circles. Remember, a tangent line intersects at exactly one point of the circle. That's my circle. Let's redo that. Okay, and there's a line, and that's the point of tangency. But tangent circles hit at one point, so that could happen inside, and they would be internal tangent circles. And that could happen with two circles next to each other where they're hitting at one point, and so those are externally tangent circles. Okay, so first we're asked to find the length of each radius. We can just count, so this would be like 1.5. So for circle S has a radius of 1.5 units, and circle R has a radius of 2 units. So just count 1, 2. Okay, and then the point of tangency is going to be a point, an ordered pair. So what is the ordered pair at which they hit? That would be, let's see, right here. So that's at -2 on the x, 0 on the y. And then the tangent line, the equation of the tangent line, since it's going to be an equation that looks like this, that's a y equals equation. So y equals, in this case, it's going to be right at the 0. So it's going to be y equals 0 for the line. Okay, hit pause, try the now you try, and hit play when you're ready to see the answers. Okay, so I counted to find the radius for each of those circles. And then for the point of tangency, we're just, keep in mind that's an ordered pair. So x comma y. And then the equation of the line, since it was a horizontal line, it's a y equals equation. And it was hitting the y at -1. Okay, and this vocabulary here, a common tangent is a line that is tangent to two circles. So if you notice, line L is tangent to both circles, and line M is tangent to both circles. And lines L and M are common external tangents. They're happening externally. And then lines P and Q are common internal tangents to circles A and B. And this theorem is important as well. So if you have a tangent line and you draw a line from the center to the edge, which would be a radius, and it's hitting that point of tangency, then it's perpendicular. We have a right angle in here. So line L is perpendicular to line AB, or radius AB. If a line is perpendicular to a radius of a circle at a point on the circle, then the line is tangent to the circle. So it's kind of like the converse of the first theorem. Okay, and if two segments are tangent to a circle from the same external point, then the segments are congruent. So if you have some external point like point A, and you have two tangent lines meeting at that point, then those lines are congruent to each other. So therefore, since HK and HG are tangents, we're told that right here, to circle F, and we're going to find HG. Well, we know that those two lines, those two tangents, are actually congruent to each other since they're meeting at the same external point. So we would do 4 plus 2a equals 5a minus 32. Solve, so you can subtract. Depends on how you want to do it. There's a few different ways. I'm doing my subtracting at the same time. So I get -3a equals -36. Divide both sides by -3, so a is +12. And we want hg, so we have to plug that back in. So since hg equals 4 plus 2a, we just plug in the 12 for a. Multiply first because of PEMDAS, and we get 4 plus 24, which means that hg is 28. And we could check our work on this one, because if you plug in the 12 here, we would get 5 times 12 minus 32, so that's 60 minus 32, which is 28, and so they came out congruent to each other, so that's good. So try the now you try and hit play when you're ready to see the answer. So my answers, I'll highlight them so they stick out a little bit more. But I got that RS is 2.1 since X was 8.4, and I plugged that back in. And I got that RS was 7, and the next one I had N was 4, but I had to plug that in.